Hi everyone, welcome back to i-NLP again, and today we'll be learning about some of the applications of the techniques what we have seen so far. So starting with, we'll be learning about question answering, and question answering is one of the most famous tasks when it comes to natural language processing, and there are plethora of methods which are getting explored even now, but there are many methods which have been explored in past. So what is the question answering task? So it involves providing a specific answer to user's query, and it can give you a rank list, or it can give you a short answer, or maybe a snippet of the answer, or maybe a kind of a full-fledged passage of the answer, right? So typical Q&A system, what we see today, one question goes in and to your system, and then answer gets generated or maybe extracted from the source text. So let's see a typical pipeline, what it used to be before introduction of deep learning methods in case of question answering. So what we used to do, given a question, we used to either classify the question to a topic, or maybe we do some sort of pre-processing with the question, and then this question we can treat it as a query. Then we can retrieve the candidate answers or candidate sentences, passages, either from the source or maybe from the web. So if you are searching the question on the web, this is what it does at the back. So given a question, it gets converted into a query, and then you are getting some top K candidates from the web, and let's say we call it a passage retrieval, and the documents are at the passage level, so we are getting K number of passages now. And then you might also get some features learned from the previous step, and what you do within those top K candidate answers, you select one of the answer. So let's say given these top K 1 to K candidates, we selected 2 candidate or maybe even 1 candidate, and either I will give this candidate document to the user, else what I can also do, we can summarize the multiple document, let's say these documents, into an answer passage. So this is what it looks like, and if we go through it in more concrete fashion, we can see that question is given, let's say asked by the user to the system, and then you might need to do some sort of pre-processing, and we'll see those pre-processing steps, what are those. And you might also want to guess or predict what is the topic of this question, so that you might want to deal these similar kind of questions in kind of very similar fashion, right? And then a retrieval part comes into picture. If you have multiple documents, you might want to filter out some of the irrelevant documents, and you want to select some top K relevant documents. And then maybe at the end, if you want the source to be at the passage level, you might want to retrieve relevant passages from the documents. And these passages are given to the answer processing or answer generation process, which will generate an answer for you. So what do we need to know about the question answering task in case of Q&A, in case of NLP? We also want to see these three dimensions, and one of the dimension is what is the source of the answer, and where to get these source from. So where to access these sources from, right? So it could be a text passage, and I will tell you, I will give you one example of this kind of question answering system where the source is just a text passage given. It could be all web documents, it could be internet search. So you are asking, let's say, where is New Delhi, and the relevant documents you will retrieve from the web. So your search engine, let's say Google or Bing, it will search all the documents available on the internet, and it will present you with the most relevant documents, or maybe snippet generated from using multiple documents. It could be also a knowledge base. So you might have heard of knowledge bases, let's say Freebase, DBpedia, and so on, where these knowledge bases are created by human beings and manually annotated. So it requires lots of human effort, and it's very hard to maintain. But those knowledge bases are super good at storing the factual knowledge and knowledge about the world, right? So you might want to generate your answer of a given question from these knowledge bases also, and we'll see one of the examples of this kind of question answers also. It could be also tables. So let's say you have a very long set of you have very long list of documents, maybe those are legal documents involving lots of tables and related to some of the stats, related to some, let's say, related to some law, or maybe some sort of or maybe it could be some financial tables which is kind of crunching lots of data related to stock market and so on, and you want to ask a pertinent question, or maybe some very relevant question which can be answered using those tables. So this could be the example of it. And then images. So given an image, you can also ask certain questions. So image might involve certain objects, and you might ask a question whether this guy is within this image or not, right? So something similar can be done. And then the question themselves can be of different type, and one of the type is factoid versus non-factoid, whether it's a factuality based question, whether there is some fact involved in the question, or maybe it's a very open-ended question. Then open domain and closed domain. So it could be searching on the web, where the documents, the source document are from all kind of topics, versus it could be a closed domain where, let's say, all the documents are related to medical setting, or maybe financial finance related documents, and so on. And it could be simple and compositional. So the questions can also be very simple, so can be answered very similar to just answering one question at a time, but it could be compositional, might involve multiple questions within a question. So more intricate, more complicated questions can also be there. So answer can also differ based on the question or based on the user requirement, and one of the answer could be just a short text, or maybe just one word. If it is a very factoid kind of question, then answer could be just one word, could be date of birth, right? So let's say the example is when the current president of United States of America was born, and so on. So it will be just a date. Or it could be a paragraph where you ask how to do it. So let's say you say that how to download a software from internet. So it could be a passage or paragraph which tells you how to do it in multiple steps. And it could also be a list where you are saying that, can you give me top 10 best performing stocks currently in India, and so on. So you'll be getting a list of those stocks. Or just could be binary kind of answer where you say yes and no. So you might say, the question might be, are there any cities in India which is bigger than the whole United States? So answer will be no, right? So that kind of binary answer can also be there. So if we go to the historical origin of Q&A systems, we can trace back it to the 1960s, and specifically Simmons et al. At 1964, they presented a work where they used dependency parsers to parse the question. So let's say this is question, what do worms eat? And then they parse it, and then answers are also extracted from the text, and then you parse them also, and based on partial matching of those trees, you can generate the answer that it should be grass here. So worms eat is matching with worms eat, and then the answer is to what is grass, right? So something similar they proposed. And let me give you some of the examples of the use cases of Q&A system. So you might have done it, and you might be doing it every day. So you might be searching on internet some of the questions you had in your mind. Let's say, where is the tallest mountain in the world? And the answer is given to you, Mount Everest, but also it says some of the things related to the answer, right? So more context to the answer. Or if you're asking a how kind of question, which is also super popular kind of questions to be asked on the internet, how can I protect myself from COVID-19? So it's listed, it kind of summarizes multiple document and lists out many steps or many options or many points. It jots down many points so that you can go through them and trying to find out what can be done to kind of protect yourself from COVID-19. So one of the most popular example of question answer system, which was Jeopardy game won by IBM Watson. So IBM Watson was a software based on some rule-based intelligence, I would say, and it outperformed, or maybe it defeated the at that time champions of Jeopardy game, and with kind of a very much ease. So it didn't feel any problem, and it kind of defeated them with very large margin, right? So, and if you see these kind of intricate, complicated system behind this IBM Watson, you will get to know that it's pretty difficult to achieve this. And you can see, first of all, they start with the question processing, which we had covered in the previous slide, that you might be doing many n number of steps, and let's say focus detection, what is the focus of this question, lexical type detection, so what is the lexical type, whether it's complicated, whether it's simpler, and so on, and question classification itself, what this question belongs to which topic, and so on, and then maybe the parsing of the question itself, like dependency parsing and so on, and maybe NER, so maybe detecting how many entities are involved, whether those entities are a human location or organization or that kind of thing, and then relation extraction, so what is the relationship between those entities and so on, and maybe on top of that, if required, maybe co-reference resolution, so if there are pronouns mentioned, then whether this pronoun is for entity 1 or versus entity 2 and so on. So you can see lots of steps are involved in the first stage of this system itself, and then you do many more steps. So candidate answer generation, where you retrieve relevant passages from your source document. It could be web, it could be a very large corpus of documents, text documents. And on top of that, you get the filtered, or maybe you get the top K relevant document, and then you need to generate the answers based on some sort of scoring. So they apply some sort of scoring based on that. They need to do away with many of the candidate answers, and they end up getting very few answers now, and then you need to generate the answer based on merging these documents. So maybe so what they do, they use kind of learn a logistic regression to rank these documents now, and they just present the highly scored document, they present that as an output. So you can see these steps here also mentioned. So after that, what happened, that deep learning came into picture, let's say after 2014 and so, and it outperformed all the state-of-the-art models, all the baselines it outperformed, and now Q&A is all about deep learning. So there is no Q&A state-of-the-art which is beating deep learning based systems, right? So we'll be learning about how do they do it with deep learning now. So some other kind of Q&A tasks which are also pretty prevalent in research community is knowledge based kind of Q&A. I had already mentioned that we might have a knowledge base like Freebase, DBpedia, and so on. And what you need to do is, given a question, you might want to visit a you want to select a particular node and you want to see the relationship with another entity, let's say Barack Obama, and the question is when the Barack Obama was born. So if this was a question, then you go to the Barack Obama entity, you find if there is something similar to the birth date or something, and you just give the other node, which is the date of birth of Barack Obama, right? Other task could be visual QA, which is also super famous and very useful in current context where the multimodality is the norm. So you can see in this picture, you have an image and then a question, corresponding question, what is the mustache made of? So a system says that it's made of bananas, right? So these kind of visual QA are also very much explored task in multimodal NLP and even vision and so on. But what we will focus on, we'll be focusing on text-oriented Q&A. And one of the example of text-oriented Q&A, and pretty important example, you might have faced these kind of questions, Q&A questions in your exams and in your competitive exams and so on. So everyone might be familiar with what is a reading comprehension. So you are given with a paragraph and you need to read that paragraph, and then there are questions asked from that paragraph, and then you need to answer those questions. So this is the overall picture of reading comprehension when it comes to Q&A. So let's say for this problem, you need to read all this stats and the words around it. And the question is, which linguistic minority is larger, Hindi or Malayalam? And it turns out that Hindi is larger because 3.3 versus Malayalam, which is 1.27. And it's super trivial for you people and for us as human being, but it would be super difficult for machine to know whether it should be Hindi or Malayalam, or might say something else like Marathi or something like that, right? So it's important to it's important for model to know the context and comprehend it better so that it can answer it better. And these kind of things can also come in other flavor, like Barack Obama educated at. So this is the question, information extraction. You want to extract this triplet. So given an entity, relationship, or maybe some question about their entity, and then the answer about their entity. So you can frame this task in form of a comprehension also, right? So question is, where did Barack Obama graduated from? And then you have a passage, Obama was born in Honolulu, Hawaii, after graduating from Columbia University, and so on, right? And other task is semantic role labeling, where let's say given a text, UCD finished 2006 championship as Dublin champions by beating St. Vincent's in the final, right? So the semantic role labeling task you might have heard maybe previously in this course itself, maybe or maybe not. So this is all about what is said to what and what is done to whom, right? So that kind of thing. So it's given a verb, whether this verb belongs to UCD, or it's saying about Dublin, or it's beating is related to Vincent's, or maybe related to Dublin, right? So this is semantic role labeling. Who is playing, who is doing what to whom, right? So that's the real question. So this can be converted into again a Q&A kind of form. So where you have who finished something, so UCD, what did someone finish, like that, right? So for finished we can generate these, for beating we can generate these, and maybe you can answer this and you can treat this as a paragraph, and these are the questions that need to be solved with this paragraph. So it becomes the reading comprehension kind of question. Okay, so a very important benchmark data set which is called SQUAD, and most of the, I would say, recent advancements or methods are benchmarked with SQUAD datasets, which is from Stanford, and it has almost 100,000 annotated passages and related corresponding questions and the answers. So, and these questions are generated from English Wikipedia. These passages are extracted or taken from English Wikipedia, and they are typically of 100 and 150 words on an average. And questions are crowdsourced. So they use a crowdsourced platform, let's say Amazon Turk or Cloudflower and so on. and they crowdsource these questions for these passages, and the answers also are annotated with the span of the text mentioned within the paragraph. So you can see in this particular example, this is the paragraph taken from Wikipedia, and these questions are annotated or maybe generated or asked by the annotators. What causes precipitation to fall? And let's say the answer is gravity. So this gravity is also they give as an span. So from this character to this character would be the answer for this question. So they need to annotate it like that. So you have 100,000 of such such passages in the question pairs. And this dataset played a very important role in advancing the state of the methods related to question answers. So it's it was super good benchmark, but it turns out that now it's pretty much solved when it comes to large language models and so on. We'll see that in subsequent slides. So some of the pre-transformer era models which we need to see, and which are mostly based on LSTMs, and then after 2019 post transformer era, I would say most of them were BERT kind of model based methods. So what they used to do, we will see these two kind of models. First of all, I think this model, which was called BiDAF, if you want to know more about it, you can read it. And they used to use bidirectional LSTMs, and with very intricate kind of architecture, and they were the state of the art prior to 2019. But when BERT came into picture, everyone started using BERT, and we'll see the BERT in detail. So for the BERT to do Q&A, what we need to do, what else we need to do? So we had seen in the previous lectures that when we are using BERT, there could be different way how can we use the BERT, right? So one of the way was you have a CLS token, and then you put all the tokens. After that, the whole passage will go in, and let's say you want to do classification. So you do this, you take this CLS tokens representation and use it in the classification header, right? But here the case is different. So we had seen sentence pair classification thing in BERT also. So it looks pretty similar to that. So you have two things rather than one sequence of the text. So you have a question, you have a paragraph. So what you need to do with the CLS, you kind of append or feed all the tokens related to question first, and then you put a special symbol or token called separator, and then you put the paragraph, right? So this is the setup we have in case of BERT. So segment A will contain the question, segment B will contain the passage, and then what you need to do, BERT need to predict the two endpoints in the segment B. So within the segment B, within this, BERT needs to find out where is the start and where is the end. And that's it. That would be the question, the answer for this particular question, right? So for an example, here's a CLS token, how many and blah 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 have, right? This is the question, and then this is the source passage BERT and blah 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 like this. Difference in BERT large is really big and it has 24 layers and so on, right? So you feed this there, right? And then how many parameters does BERT large have? So it will be this, right? So let's say it says that 340 million. So the BERT, now at the end of the day, you need to predict this start and end span. So it will say from this character to this character will be the answer. So that's what the BERT is producing here. Or in terms of equations also, you can see that this is the start and this is the end. And you need to negative log likelihood, you need to maximize the probability of predicting the start and end positions. And you can get it from a softmax. You apply softmax, you get the for probability for the start and probability for the end, right? Okay, so what about the performance? Did we get better performance with this? Yes. So it turns out that compared to the BiDAF, and this is the human performance. So when humans are given this squared data set to do maybe for a particular test set, how well they performed versus how the machine learning models are performing. So this BiDev based on the bidirectional LSTM, which was the state of the art, you can see you just get 77.3 F1 score. And when it comes to BERT base itself, so not the BERT large, you can see the significant gain with the BERT base. And in case of BERT large, you can see the huge difference between the BiDef and the BERT large. But it doesn't stop there. So you can see the better and better models, a bigger model. So XLNet, Roberta, NLBERT, all are bigger than BERT and having some other properties. So they are outperforming BERT even, right? So if you're scaling the model and these large language models, you are getting more and more increased performance in terms of FN score and EM, right? So you can see clearly the transformer-based models are outperforming the RNN-based models here. So one other spatial case of BERT proposed by people from Stanford, I guess, it's called span BERT. So what did they do? Rather than using the masked language model, so rather than using masking 15% of the, we had a discussion about BERT, we had seen what BERT does is given a sentence, it masks 15% of the words, and then the task or objective of the pre-training is to predict this word, and we know already that word because we have masked it, right? So that's what the objective of pre-training for the BERT. They changed the pre-training objective to span of the words. So rather than just masking some of the words, you mask a span of the words, multiple words. Let's say 4 words are masked, and then model needs to predict these 4 words, right? So and it turns out that it outperforms the BERT pretty easily. And why it does so, the kind of justification behind it or intuition behind it, that we want to predict the start and end token, right, when we are doing Q&A. So in a sense, if we mask the answers and ask the question, then model is able to predict the whole span of the words, so whole number of multiple words, rather than in case of normal BERT, we were predicting just one word at a time. So I think this particular pre-training objective is more suitable for Q&A kind of task. So that's why it outperformed. So one of the other kind of questions or Q&A tasks are open domain Q&A. So what do we mean by that? So in case of reading comprehension, we have a question, we have a source passage. So we know that answer will be here, or maybe answer will not be there. Maybe a negative answer or positive answer might be there. So it depends on what kind of task it is. So this is the setup for reading comprehension kind of Q&A. But in this case, what happens? We have a question, but we don't have a passage. We have multiple documents, or maybe we have thousands of documents, hundreds and thousands of documents. Let's say the whole web. So we have whole web in front of us to answer this particular question. So that's called open domain, right? And we are not kind of categorizing topic wise and creating a subdomain out of it. So we don't know whether how many topics are there, how many documents are there for a particular topic. So all these kind of stats are not available to us, right? So this is the typical scenario of open domain. So what are the challenges here? So in case of reading comprehension kind of Q&A, the scope of the answer was very limited, right? So the scope is just this much, this passage. On the other hand, the scope of the answer here is unlimited. So we don't know where is this answer. So it cannot be done in similar fashion what we had done in case of reading comprehension. So let's say, just to tell you the setup, input is a large collection of documents, let's say D1, D2, and so on. And there is a question called Q. And we need to output a string called A as an output, right? So what the other paradigm, there is a called retriever reader paradigm proposed by people, researchers, which says that first of all, you need to retrieve the documents and I will tell you the intuition behind it, and then you read those retrieved documents. So why this retriever step is there? So retriever step is there to filter out all the irrelevant documents. So let's say you have 10,000 documents, and it's even smaller compared to the real world, right? So let's say you have 10,000 documents in total, right? So 10,000 docs, right? Then what you do based on the query, you retrieve some of the relevant documents. So you retrieved only, let's say, 100 documents. So you are doing away with lots of garbage or irrelevant documents, and you are left with just 100 documents. Now in terms of processing, in terms of computational cost, in terms of memory, you will be pretty optimized and efficient, right? So one of the reason is this. So these documents, these 100 documents what you have retrieved, they are pretty relevant. So answer might lie in these 100 documents themselves, right? Now what you need to do, you need to utilize these 100 documents in a reader now. So this reader will read these documents and it will find out where there is a two particular document or one document where the answer lies. Or maybe you want to crunch multiple documents to come up with a passage of answer or a snippet, right? So there could be multiple of such cases. So they propose this Dr. QA method, and for a retriever they used TF-IDF, term frequency inverse document frequency based information retrieval. So you don't have to worry about it if you don't know it, but I think if at all it had been covered in the previous lecture, that's super good, right? So it's based on some stats, whether that word is present in the document, this word. It's a kind of a lexical matching, so word to word matching, right? So a sparse model which they use for a retriever to filter out all the irrelevant documents, and then as a reader they used a neural network. So they use a neural network for reading and for retrieving the very classical TF-IDF, which is very simple and efficient to compute. So how it looks like? So what they do this. You can also do joint training of this retriever and reader. So here it is the BERT representation of your query. So you given a query. Let's say this is. Let's say there are 3 words in the query, right? It goes to the BERT, right? And you get a single representation, a vector representation of it. So this is written here. So what does this zip in zip code stand for, right? So this might be going in, and then what you need to do, you also have these documents which are present to you, maybe just 100 documents, right? After doing this TF-IDF kind of retrieval, so you're left with 100. So you also encode those 100 documents with BERT, and then you compute some sort of similarity, let's say dot product itself, right? And then you choose these top K now again, right? So you chose this top K, and then with these, and with these top K, you need to generate the answer. So that's the overall architecture of retriever reader model, right? On top of that, there is a method called dense passage retrieval, where you need to encode the query, you need to encode the passage as the passage level rather than the whole document level, and simply you need to compute the dot product between them. You get a score, and you retrieve most relevant document by sorting them in descending order and taking top K from the list, right? So you can see the difference here. This was again a BM25 method, which is the classical method of retrieval, how we do compare to that. And then you can see how much performance we are getting, the improvement we are getting based on if we increase the trained data set. So if we start increasing the trained data set and we train this model, particular retriever reader model, we are outperforming BM25, which is also a super good model, but it doesn't involve any kind of learning, but it's more of stats oriented model. But it outperforms pretty easily BM25, like with very high margin, right? So you can see the kind of beauty of neural models when it comes to Q&A. Apart from that, what you can do, what we were doing, we were, as I said, that BERT will output two positions in the passage, source passage, right? So start and end, right? And the answer will lie within these two span, right? So within these two boundaries, right? So that's what, and this is called extraction. So we are just extracting where is the answer within the source passage. On top of that, what you can do, rather than doing this, model can also generate the answer. So it is not extracting the answer, but it's generating the answer, right? So text generation. So we had covered this in text generation lecture, right? And you know already T5 model. So BERT is not good at generation because it's not a autoregressive model, right? So it's not a generative model, right? So that's why I use BERT as encoder rather than a decoder, right? So we'll be using seek-to-seek model, and T5 is a seek-to-seek model where we encode the sequence and decode the sequence. So what you do, this DPR we had seen in the last slide. So we retrieve the passages, relevant passages based on the query representation we get from BERT, and the document representation. We compute the similarity between them using dot product, and we get these outputs and we feed them to T5, the top K, like it's written here. So question and passage 1, question and passage 2. You feed that into the decoder side. We concatenate the representation, we feed this to the decoder, and at the decoder at T5, we generate the answer. We don't extract the answer from the passage, but we generate the answer, which is very convenient, but it's more challenging, right? So you need to factor in some sort of abnormalities which might be there in the generation, let's say repetitiveness or maybe coherence and so on, right? But it's super good, right? So, and it kind of, it's a origin of all those generative LLMs, right? So GPT and so on.